Welcome to David Alexander Maths Tuition. This is chapter 4a on cubic graphs. So again, this is a topic you might have done at GCSE, but I feel like at this stage we're now getting into some harder stuff, like new stuff as well. So what we need to remember with a cubic graph is if it's a positive cubic graph, it will go up, then down, then up again, or it might just go up, slow down, and then continue up. Whereas a negative cubic graph will go down, up, then down again, or it will go down, it will slow down and continue back down again. Now this is a positive cubic because x times x times x is x cubed. Don't worry, we don't need to expand the brackets or anything, but we know what the roots are. If we set this to 0, then we've got x equals 8, x is negative 2, and x is plus 4. So these are the x-intercepts. Okay, so there's my x-axis, there's my y-axis. So we're cutting through at negative 2, positive 4, and positive 8. Okay, so it's only a sketch. We don't need to be too concerned as we're just marking in the x-intercepts. We could also work out the y-intercept as well, which is negative 8 times positive 2 times by negative 4 if we wanted to. So 8 times 2 is 16, times by 4 is 48, so it's also cutting through at 0, 48. Okay, well, it's going to be miles up here, but I can always just, it's just a sketch, so we don't need to panic. So it's a positive cubic, so it's going to look like this. So we're going up through 2, then down through 4, and back through 8 again. So for the sketch, it's not asked anything about maximum or minimum turning points, so but I also do know, by the way, that this is 48, so we could mark that on if we wanted to, but I think the key thing is knowing that it cuts through at negative 2, positive 4 and positive 8, and it's generally got this up, then down, then up again shape. Okay, so here we've got another cubic, so the intercepts are going to be 0, negative 3 and positive 5. So again, we'll just do a sketch of our axes, so 0, negative 3, positive 5. As it's a positive cubic, it's going to be going up, then down, turning around, and then coming back up again. Okay, so for this one, we've got x minus 7, x minus 7, x plus 1. So we've got the roots of positive 7, and minus 1. Well, we don't need to write it twice because it's just completely unnecessary. But what does it mean when there is a repeated root? So let's just do my little sketch. So we know it's going through negative 1 and also plus 7. Now this root that is repeated, that means the curve turns around at this point, so it will touch 7. In other words, the x-axis is a tangent to the curve at this point. Anyway, so let's just plot it. So we know it's a positive cubic, so it's going to go up, then down, then up again. So it's going to go up through negative 1, and it's going to turn around, but it's not going to go through negative 7. It's just going to touch negative 7 before it takes back off again. So when you've got a repeated root, remember, it just touches that point. It doesn't cut through it. Okay, x plus 3 cubed. So we're only going to get one solution, which is negative 3. And what that means is that at this point, negative 3, this is one of the ones where it doesn't go up, then down, then up again. It will just go up, slow down, and then move back up again. So if this is the point negative 3, the graph will the line will come through here, the curve will come through here, and then it will take off again. There we go. So here it's just cutting through once at negative 3. Okay, this one's a bit more problematic. We know it's a negative cubic because it's minus x times minus x times minus x is minus x cubed. So if we were to make it equal 0, as usual, then we've got minus x minus 2, another minus x minus 2, and another minus x minus 2. So if we're multiplying all of them together to get 0, then one of them needs to be 0, in which case, let's say it's the minus x minus 2 that equals 0, so negative x equals positive 2, so positive x is negative 2. So negative 2 is the only root we have, and when a cubic only has one root, then that means it's just cutting through there. It's not going down, then up, then down again. We don't have well, it just means we've just got the one root at -2. So here's my sketch, that is -2, and I'll just show the line, or show the curve going through there, and then just taking off in that direction again. So again, it's just a sketch. We don't need to plot anything else. I mean, we could work out where the y-intercept is, which would be -2 times -2 times -2, which is -8. So if you wanted to show it cutting through the axis, which the way I've drawn it would be off the screen, it would cut through at -8. But for a sketch, we don't need to be that precise. Most of the time, it's just a case of showing, getting the vague pattern of the graph, vague shape of the graph, I should say, correct, and showing where it's cutting through on the x-axis. Factorise the following equation and then sketch the curve. Okay, so I can factorise this by taking out an x, and that will leave me with an x squared plus 7x plus 10, and the x squared plus 7x plus 10, that will go to double brackets, so x plus 5, x plus 2. So if we set it all to 0, we're going to get a solution of 0, -5, and -2. So we can do a sketch here. We know it's a positive cubic, so it's going to be an up, down, and up, and it goes through 0, -2, and let's say -5. So that means it's coming up through here, down through there, and back up through the origin. Okay, I missed using my graphics tablet there, but I'm sure you get the idea. Factorise the following equation and sketch the curve. Okay, so again I can take out an x, so that's going to be x, lots of x squared minus 9, and here this is the difference of two squares, so that's going to be x, x plus 3, x minus 3. So my solutions are 0, -3, and +3. So 0 plus 3 minus 3 is a positive cubic, so it's going to go up, then down, then up again. So it's going to go up through -3, down through the origin, and up through 3. Sketch the following curve and indicate the coordinates of the points where the curve crosses the axes, so plural. Okay, so this is x plus 2 cubed, so x plus 2, x plus 2, x plus 2, and you're only going to get one solution, which is -2. So we know that it's a positive cubic, and if there's only one solution, then that means it's going to look like that, cutting through at -2. But we also know the y-intercept will be 2 times 2 times 2, which is 8. So we need to make sure that we show 0, 8. Okay, so this is -2, and let's make this 0, 8. Okay, so it's coming up through here, cutting through there, and going up. Okay, that's a fairly poor sketch. Maybe I should just show it going down, maybe more that way. But the key thing is that you're showing a vague shape of the curve. Again, it's gone a bit wonky over here as well. It's cutting through at -2. So it's going through -2, 0, and it's also cutting through at 0, 8, the y-intercept. The graph of y equals x cubed plus bx squared plus cx plus d is shown below. What are the values of b, c, and d? Okay, so what we can see is that it's cutting through at 6, so we've got the coordinate 0, 6, and we've also got, well, the most important thing is the x-intercept. So here we've got -3, here we've got +1, and here we've got +2. So if these are the solutions, then it's going to be x plus 3, x take away 1, x take away 2, or a multiple of that. It all depends whether we get 0, if we can get the y-intercept of 6. 3 times -1 is -3, -3 times -2 is +6, so it does work, so that's good. Okay, so all we need to do now is expand the bracket, so I'll just do these two first. That's going to be x squared plus 3x minus x minus 3, so x squared plus 2x minus 3, multiplied by x take away 2, so x cubed plus 2x squared, take away 3x, and multiply everything through by -2, so minus 2x squared minus 4x plus 6, and that will give me x cubed 0x squared minus 7x plus 6. So B will be 0, C is negative 7, and D is positive 6.